The graph shows f of x is equals to e to power x minus 2x. Find the range of f of x. Now, to find the range of this function, we need to find the minimum value of this function. Okay, so we need to be able to find the minimum value of this function. Okay, to be able to find the range. So we need to find the x value at this point before we can be able to find the value of this function at that minimum point. And after that, we'll be able to know how to, we'll be able to just write down the range of this function. So the hint here is to find the range, we have to find the minimum point. To find the range, we have to find the minimum point. Okay, so step one, we need to find the first and second derivative. So step one, find the first and the second derivative. So to find the first derivative, we just need to differentiate that function. So the first derivative will be e to power x minus 2, and the second derivative will be e to power x. So after that, our step 2 will be to find the critical values of x by setting the first derivative equal to 0. So step 2, we need to find the critical values of x by setting the first derivative equal to 0. So which means we need to take our first derivative and equate it to 0, which is e to power x minus 2 is equals to 0, which means e to power x is equals to 2. Now we need to find the value of x. So what you can do is just change this from exponential form to logarithmic form. So rewrite from exponential form to log form. Okay, so what that means is that this expression here will be log to base e of 2 is equals to x, which means that x will be equal to ln2, because you know that log to base e of 2 is same as ln2. Okay, so we can carry on to step 3. So step 3, use the second derivative to determine if we have a maximum or minimum point. So use the second derivative to determine if maximum or minimum. So what that means is at our critical point, okay, at x is equals to ln2, what will be the value of the second derivative? Okay, so what will be the value of the second derivative? So we need to plug this into the second derivative. And by the way, the second derivative is this one here. Okay, so we need to plug that into our second derivative, which means we come over here. So we'll have e to power ln2. And e to power ln2 is just equal to 2. You can check your formula booklets for that. So which means that we have a minimum since the value of the second derivative is greater than 0. Okay, so we have a minimum point. So step 4 is just finishing this off. So step 4 is to find the y coordinate. So to find the y coordinate, we just need to plug in ln2 into the original function. Okay, just need to plug ln2 into the original function. The original function is e to power x minus 2x, so that will be equal to e to power ln2 minus 2 ln2. Okay, 2 ln2, which will be equal to 2 minus 2 ln2. Now, this is the minimum value of, by the way, this is the minimum value. This is the minimum value of f of x. Okay? What it means is that this point here, this point is 2 minus 2 ln2. Okay? So we can be able to now finish off to write the range. So you can say, so the range of f of x is y is greater than or equal to 2 minus 2 ln2.